Okay, so let's start. Okay, we'll do one example. Okay, and I call this as guessing game. Guessing the number game. Okay, so let's say you think of a number. Okay, say 65, and now you need to guess which number the user has thought of. So what do? You will you will take it as input, correct? So I'm saying here guess equal to int of input, guess the number, right? And if there is a match, if num1 equal to guess, we say print you guessed it right. And else you'll say print sorry, you couldn't get it right. Okay. Okay, so this is the game, right? So now when you run it, okay, so I'm saying guess the number, and if you guess it wrong, it says you couldn't get it right, right? And if I say 65, you say you guessed it right. Okay, so simple example. Okay, but now let's say that I want to guess, or I want to continue playing. Okay, I want to continue playing till I get it right. Okay, so till I get it right, I want to continue playing. So you have to put this in a loop, isn't it? And guess the number has to be in a loop. That's when you keep on asking, guess the number, right? So I'll say while true, because I don't know how many times you will take to guess the number. You might guess it in first attempt, you might take 10 attempts to guess it. So just to save that, I will say while true, so that okay, your loop goes on. And then, I'll put this inside this, so it becomes a infinite loop. Okay, perfect. Now, if I run it, what happens? Even if you guess it right, okay, you will go on forever, right? But with the moment you guess it right, you should be thrown out of the loop. Then what should I do?
Break.
Break, right? So if you apply break, okay, your loop will break. So where should I apply? I should apply break here. I should say that if you get it right, you please stop. No need to move ahead, right? You please stop. No need to move ahead. So you put a break here. Okay. Okay. So now when I run it, so I say 76, okay, it says wrong. And now I say 65, it became right. Okay. Next. So now if you don't get it right, okay, then what happens? Okay, you keep on running it. You don't know, okay, whether whether the values that you are giving, is it correct or not, right? So okay, so at least you know what it is correct, but it's not helping you, right? So if I enter 76, it says incorrect, but is it low or high? We don't know. So it would be a good idea, correct, if it gives a hint, correct? If this gives a hint, it would be a good idea, right? So we will add hint to this. That means when you get it wrong, okay, so when you get it right, you come out of the loop. That's fine. But when you don't get it right, okay, we should, our program should tell us whether, okay, whether this is less, okay, or more, low or high, correct? So let's see that. Now, okay, so we are only handling else. Else is only if it is not correct. Now, if I need to check whether it is, less or more, I have to break this. I have to break this into two parts. One, if the guess number is high, and other if guess number is less, right? So I'm going to say here, okay, let's have else as it is. And before that, I'll say elif num greater than guess. So if num is greater than guess, then what do you want to print? Sorry, it's incorrect. Sorry, it's incorrect. Guess a number lower or higher. So the number that you have to guess, should it be lower or higher? See, num is higher. That means you have guessed 55, 45, right? That's why number is higher than the guess. So I should say guess a number higher. Guess a higher number, right? Guess a higher number, correct? Makes sense, no?
Yeah.
Right. Similarly, here I will copy this and I will say guess a lower number. Now let's play this game. Guess a number 55. So it says guess a higher number. Now I'll guess 76. It says guess a lower number. Now I'll say 65. You got it right. So let's add one feature to this. What is the feature? To tell us how many attempts you took to guess it correctly. Okay, how many attempts you took to get it correctly. So I'm going to have a variable called attempts, right? This should be set to 0. And every time you're reading a value, correct? Every time you're reading a value, it's like making an attempt, isn't it? So I'm saying attempts equal to attempt plus 1 every time you are guessing the number, every time you are reading the input. And now here I'll say you guessed it right in so many attempts. So this attempt is text and this attempt is variable. And when you are putting variable inside this, you have to put F format string, right? So now when you run it, say guess the number. Guess the number what? 78, 99, okay, 20, 35, 43, 65. So it took us 5 attempts to guess it. Make sense? Now, let's say we limit the number that you think of. Okay, so I'm going to say guess the number between 1 and 100. So I only want to guess the number between 1 and 100. Okay, so if the number one num, okay, is more than 100 or less than 0, what should you do? You don't have to okay, Okay, so for example, here I'll run it and I'll tell you what I'm meaning here. So you have guessed the number between 1 and 100, and let's say I put here 100, 200, correct? Now 200 is definitely higher, but when the number is 200, I don't want you to go here. Instead, we know that this cannot be the number. So it should start from while here itself. See, when you know that this 200 cannot be the number, then why do you have to go through, um, you know, um, all the other steps, isn't it? When you know that it's not possible, okay, let's say you're living in a city where there is no beach, okay, and if I tell you, oh, go to the beach, you know that beach is not there, then why will you say that, okay, let me go and check? Will you go and check and roam all the city and then you come back saying that, oh no, I did not find beach? Okay. If something is possible, only you will go and try. If it is impossible, okay, then why do you even have to try? So in this case, what I will do, I will put another if condition here, and I'm not increasing the attempt also. So if you are guessing incorrect values, something beyond 100 or less than 1, outside the range of 1 and 100, I don't even want to count it as an attempt because you made a fall attempt. So I don't want to count it as an attempt. So I will say here, if, okay, if guess is less than 1 or guess is greater than 100, correct? So if guess is less than 1 or guess is greater than 100, then what do you want to do?
Break.
Okay, no, break will throw you out of the loop, right? Your loop will break. I don't want to break the loop. I want to continue from the beginning, right? Break is to throw you out of the loop, right? I don't want to throw you out. I want you to start from beginning. Okay, I want you to start from beginning. So I will say continue. So just like break, continue is another keyword, okay, which will take you to the beginning of the while loop. Okay, which will take you to the beginning of the while loop. Clear? So the moment you hit this, okay, your all these lines will not be called. It goes to the beginning of the while loop or any loop. Okay, you can use it in for loop also. Continue will take you to the beginning of the loop. Okay, you don't have to execute anything beyond this. Is it clear? Okay. So now let's see this. Let me run it again. So see here. Now, before just saying continue, okay, let's give some message here. Print. Your guess is outside the valid number range. Try again. Okay. Now we can have one more logic to this. If he does it again 2 times, if you do it, then you lose the game, right? So okay. So what I'll do here, I will count one more variable called false equal to 0, and here I will say false, okay, equal to false plus 1. Okay, your guess is outside the valid number range. Okay, and now I'm going to put in the same line, I want to add, okay, another sentence. So what I'll do, I'm going to check if false, okay, equal to 0, or I can check it after or before. Okay, so if false equal to 0, that means this is your first fall. Print. This is your first fall. So you can continue, but another fall will another fall will what? I mean, will will throw you, or another fall will make you lose. Make sense? So this is if false equal to 0. Okay. Now elif. Now see, I'll do else only, because the moment false is not 0, if it is 1, okay, I'll put a break anyway. So I'm going to say okay, this is your second fall. Sorry, you lose. Okay. So let's see what happens. I'm going to run it and I'm going to say, guess the number between 1 and 100. I say 35. It says guess a higher number. One attempt gone, right? I say 90. Second attempt gone. Now I say 200. So your guess is outside outside the valid range, number range. This is your first fall, so you can continue, but another fall will make you lose, correct? So 1, 2, 3 attempts, 1, 2 attempts gone, right? I'm not counting this attempt. So, okay. So 1, 2, and now let's say 65 I give. So see, you guessed it right in 3 attempts, correct? Now you can have one more logic here, okay? 3 attempts and 1 fall or no fall, okay? Now if I try to run it again and I will give 0, right? And if I give 200, see? Oh, this is second fall. Sorry, you lose. And then I'm not doing anything. So I need to do break here, right? Because when you lose, you should break and you will be thrown out of the program. So let's give 65 here. See, it says you get it right in first attempt, right? We're not counting these attempts. So it only says first attempt. So now I'm going to say 0 and 0. You see, your guess is outside the valid number range. This is second fall. Sorry, you lose. All right. Do you understand this simple program? Now let's talk about okay, so we'll continue. Okay, so see what we have done. We have built a simple program to guess the number. Okay, now let's say, okay, here we know the number, right? It's visible. We know that it's 65. So that, we are playing at for our convenience. Okay, I want to get it right in first attempt. We get it right in first attempt. We want to get it in fifth attempt. So we play for 4 times and then we get it right on fifth attempt, right? Because we know the number. How about this number being a truly a random number? So we want machine to think about this number, right? Not we, right? So is there a way we can do it? Yes, there is a way we can do it. Okay. So there's something called as modules. Okay. What is a module in Python? Module is a collection, is a file. Okay. Basically, module is simple file, just like we have prog1 or June 2023 or py18 or py1. These are all file names. So your modules are also files, okay, which have functions, right? So just like we created our own functions the last time, and just like we have used inbuilt functions. So what generally people do is the related functions, they put it in one file. Generally, the functions which are related, okay? So if they're related, we'll put it in one file so that it is easy to remember that, okay, this module has these files. So we have a module called as random. We have a module called as random. Random module has functions related to generating random numbers. So random module has a function related to generating random numbers. Okay. Now, there are some functions like print, okay, input, and all those functions that we have used so far, they're all global functions, and we are able to use them, okay, without importing without telling where the print uh, function. See, print, input, all these are functions. So even these will be somewhere, isn't it? These will be saved in some file, but those files are global, so we don't have to tell that, okay, pick print from so and so file. So the functions which are very commonly used, they have been added in the global file, and you don't have to indicate, you don't have to tell Python where to pick the functions from. Now, specialized functions, which are designed for special tasks. Now, these functions are not used by all the programs. So right now, in this program, I want to talk about random number. So I need random number function. But not all program you'll be using random numbers, isn't it? So this is not as important as print. Okay, you can't imagine a program without print, right? Okay, input, right? So these are used in every program. So if they're used in every program, say, okay, let us put it in the global function and let's make it available to all. Now, if you make all the functions available to all, then your program will be slow. All those functions will be attached to your file. So to make sure that now our program, okay, the editor that we're working on, the Python program that we're doing is not bulky, it's not impacting, okay, it's not impacting your performance of the programming. So what they say is, we will attach only the important functions. We'll attach only the important functions, not all the functions. So functions which are specialized, we will have to ask the user to tell us. Okay, so the common functions are attached. We don't have to tell. As a programmer, we don't have to tell. But specialized functions, we have to tell to the Python that include those functions, include those modules. Okay, so for example, okay, in random, there is a function called random. So random module, okay, has a random function. So module name, that is file name, and function name is same. So we will also learn to create module. Okay, later we'll create our own module. So what random does, random generates random number between 0 and 1. So if I say print random, it will print sometimes 0.35 or sometimes 0.45, anything. Okay, it generates a random number between 0 and 1. Then you have something called as random int, rand int. Rand int is a function which generates random number between given integer values. So in this case, we want to generate integer values only, right? Between 1 and 100. So what I have to do, I have to first tell Python that import random, import module name, import module names. I'm importing module name called random. Okay, so great. Now here I'm going to say random dot rand int. Rand int is a function, okay, which will generate random integer values. Okay, and here I'm going to say 1, 100. So I'm saying randint is a function which belongs to random module. So module name dot function name. Okay, so randint is a function which is in module called random. And random dot randint 1, 100, I'm saying randomly select a value between 1 and 100. So now every time we run this program, num1 will get a random value which nobody knows which value it will pick. So now this game becomes a truly guessing game. This is how machine, okay, will be able to generate random values. You have a random module, and using that we can generate random values. Okay, so let's run this program now. What happens? Guess the number. Okay, now come on, guess the number. Let me see if you can guess it. How many attempts you take to guess it? Give me a number, guys.
71.
31. Okay. So it's incorrect. What's your next number?
74.
74.
81. 94.
94. It
91.
means it is between 81 and 94, right? It means it is between 81 and 94. So now you have to guess a lower number.
91.
91. Okay, 91. Next.
85. 84. Sorry, 87.
Okay, let's make it 87, you said. 86. Finally, you got it right. 86. Took you 9 attempts to guess it. Make sense?
Yes, sir.
Okay, so this is how you can play this game. I'll make one more change to this. So this is about, okay, okay, so guess the number game. Computer will think of the number and we will guess it. So it's like computer versus human, correct? Now, can we design a game where we play computer versus computer? That means computer will think of the number and it will only guess it. Okay, so instead of we saying guess equal to int of input, what we will do, we will say random dot randint 1, 100. Okay, so computer is only thinking and computer is only guessing, right? So we took almost like 9 steps to guess the number, right? Now let's see how many steps computer will take to guess the number. Oops, we are have to run this program, right? So I'll stop it here and I'll say P1 run. Okay, 4 attempts, not bad. 348 attempts. Why do you think it took 348 attempts? Number itself is between 1 and 100 is 100. To guess 100 numbers, it took 348 attempts. What is the flaw in our design? Is there any flaw in our design? Of course,
It
right?
repeated the guessings,
It repeated the
guessing numbers. Yeah.
It repeated the guessing numbers. Why? Why do you think it?
Because all guesses was random, it was dependent on the previous one.
Yeah. So see, every time we are guessing it. See, when you're playing mentally, when we are playing our game, we know, okay, it says 35 is, okay, when we say 35, it says please enter a higher number. So we know that we should not be entering a number less than 35. But we are randomly saying 1 to 100. So randomly it will generate, even though 35, it says enter a higher number, it will enter 25, 21. It will think 21 twice also because randomly it is guessing the number, right? So that's the problem
Yes,
with
sir.
this program. We have to make it intelligent like us. Just like we think, we have to make it also think, isn't it? That means you see this. Okay. When the guess is number is greater than guess, that means your guess was, let's say, 35 and number is 65. So when your guess is 35, next time it should search between 36 and 100, not 35 or not 1 to 100. Correct? So what I will do, I will introduce two more variables called low comma high. And initially it will be 1 comma 100. First guess will be between 1 and 100. So I will say low comma high. First guess is between low and high. Perfectly fine. But second guess, it has to be intelligent. So if you guess a lower value, if you are here, let's say, okay, if you are here, that means you are guessing a lower value, right? That's why it says that think of a higher number. So in this case, your low will be guess plus 1. That means if you thought of 35 and 35 is low, that's why it says think of a higher number. The lower value should go up to 36 now. Guess plus 1, 35 plus 1, 36. Your guessing should be between 36 and 100. Similarly, if you guess a higher number, let's say 99, so the high number next should be guess minus 1. If you thought of 99, the next high should be 98. Correct? So now we are reducing the range. Now when you run it, see, it also took nine attempts like us. Yes, it will be plus or minus little bit, right? But it will not be like 50 or 100 for sure. 5 attempts, 9 attempts, 6 attempts, 8 attempts, 7 attempts, right? Somewhere near 9 attempts only it's taking. Just like the way we took 9 attempts, right? But it's not going to take 15, 20, 30 attempts. It will be less than, okay, 10, 15 only. Right?
Yes, sir.
Let me add one more feature to it. I want to see, typically when you guess the number, okay, typically when you guess the number, on average, how many steps do you take? Now, what we have done here, okay, is we are running multiple times. Sometimes it's taking 4 attempts, sometimes 9 attempts, 4 attempts, 5 attempts. If I ask you, typically how many attempts it takes? So you cannot say 4 or 9. We have to take average and say on average it takes so many attempts. So what if I run this program, let's say 1000 times? Okay. Finding average of running this average attempt. So I'm going to say, okay, attempts. Okay. So, okay. So, okay. So I'll create a total attempts variable. Okay. Now this will calculate the total attempts. Okay. And I'm going to run a program or this entire program, let's say 1000 times for I in range 1000. When I say 1000, that means it's going to run 0 to 1000, 999, right? I'll put entire thing in this. Okay. Now what I'll do, okay, every attempt that you are setting up, right? Every attempt I'm saving in this total attempt. So where is equal to here? Here, right? So I'm saying total attempts. Okay. Now when you say plus equal to, it means it's like saying total attempts equal to total attempts plus attempts. Okay, so A plus equal to B, okay, is same as A equal to A plus B. Okay, if I say A minus, or let's say A divided by equal to C, okay, this means I'm saying A equal to A divided by C. Okay, interchange the sign and repeat this left side variable. So if I say total attempts plus equal to attempts, it's like same as saying total attempts equal to total attempts plus attempts. All right. So once you are here outside the loop, when you are done running it, doing 10,000 or 1,000 times, so now we can say on average, this program has taken attempts. So what should I write here? So here, total attempts is the total attempts. And if I divide by 1,000, that will be your average number of attempts, isn't it? And now I'm going to format it saying 0.1f. I just want 1 decimal point. Now when you run it, so it's going to run 1,000 times, and see it says on average, see if you scroll up, you'll see 1,000 times. So it says on average, it has taken 7.6 attempts. On average, it has taken 7.6 attempts. All right. Any questions so far?
No.
Okay. One more feature let's add to this. So what we just saw was calculating total number of attempts. Now, can we measure the time, number of seconds that it has taken to, okay, number of seconds it took to execute the program, right? So let's do that as well. So to work with date, okay, so there are again packages, sorry, modules, packages collection of modules. We'll talk about it later. We'll stick to modules for now. There's one more module called time. So if you want to measure only time, you have time. If you want to measure only dates, days, months, year, we have date. Okay, so you have date, you have date time. If you want to measure both date time, we have a module called date time. So it has date time related functions. Date has only date related functions. Okay, time has time related functions. So for today, we will use only time. Okay, so we will use time. Fine. So how do I measure? So what I'll do is this is the start of the program, correct? So I will measure the start time. So you measure what is the time now. So what is the time now? Time will tell you, it'll read the time from the clock here, right? In my clock, it is 21:28 and some seconds. It goes to microseconds, right? 0.6 digit. It goes to that so many, accuracy value. Okay. So second, 0.6 digit. Okay. So I'm going to say start equal to time dot time. And what I'll do here, you do here end equal to time dot time. So I'm measuring the time when the program started and I'm measuring the time when program finished. Okay. And that will be the total time taken, isn't it? Print. Total time taken by the program to run. Okay, I'll make it 10,000 attempts. I'll say 10,000. Okay, I'll say here 10,000. Okay, total time taken by the program to run 10,000 time is so many seconds. How many seconds? So you will say end minus start. So you measure the time when started. Let's say, if you want to know how many hours did you take to reach your destination. So I'll measure the time at your origin and I will measure the time at your destination. And if you subtract, that is the number of hours, isn't it? So same thing I'm doing here. Okay. I'm measuring the start there. I'm measuring end here. And end minus start will give you total number of seconds. So let's see. So see, it took us almost like 3 seconds. 2.9799. That means almost like 3 seconds. It took 3 seconds to run 10,000 iteration of your program. Some program will be longer, some will be shorter, right? On average, it is 7. Okay. So see, 2.8, 2.9, 2, 3. So this is how you can measure the time as well. Okay. So it on average, it will be same. If you do more, that's why see, when we say probability, why do we say probability? Now, when I say probability of tossing a coin is 0.5. Okay. So that means if you toss a coin 2 times, okay, one time you will get head and one time you will get tail. But if you run it, okay, 1 time, 2 time, you will not see the probability. It can happen if you run 10 times, you might get 7 times head, 8 times head. But when you run it 1 lakh times, when you run 50,000 times, okay, when you run 50,000 times, then you actually see that, okay, out of 50,000 times or 1 lakh times or 10 lakh times, you'll see that, okay, 50% is head, 50% is tail. Over long period of time, you get average, that probability. You don't see probability when you run 5 times, 10 times, 20 times. It can happen that 15 times after 20 times, you get head only. But if you run 10,000 times, then definitely you will get a value closer to your probability. Make sense?
Yeah.
Okay. So this is how you can run. So today we saw examples of 2 modules called random and time. Okay. And of course, you'll have more such examples we'll talk about. Okay. And you need to practice. Sounds good? So we'll continue for a few more minutes. Okay. Let's introduce the topic that we're going to talk about next. They're called as collections or complex data structure. So we discussed about data structures, and these are complex data structures. Complex data structures means they can store more than one value. That's why they're called as collections. Okay. So your int, float, string, you only say one value. But when you talk about collections, that means you're talking about more than one value. You're talking about more than one value. Okay. So here we'll talk about 4 important collections: list, tuple, sets, and dictionary. As the name suggests, they will store more than one value. So let's look at list. Okay. So I'm going to say L1. Now, the way you define list is using square bracket. The moment you see a square bracket, it means you are saving here multiple values. You want to store multiple values in this list. You want to store multiple values in this list. Okay. So I can store as 10, 20, 30. You can store string as well. You can store Boolean. You can store any values. Okay. You can even store a list inside a list. Okay. You can store a dictionary inside a list. You can store tuple inside a list. You can store sets also inside a list. We'll do that. We don't know what sets and dictionary is as of now, right? But you can store them also inside a list. Okay. List is simply a collection. Okay. So if you want to print the type of this variable, type of the variable equal to type of L1. Now, when you run this program, see, it says list, class list. Okay. So if I ask you what is the size of list? What is size of list? Size of list means how many variables are in the list. How many values, sorry. Variable is only one, right? Tell me, guys. So we have a function called len. Len will tell you how many values are there. So what do you think the output will be here?
6.
Okay, so let's see. You get 1, 2, 3, 4, 5, 6. Yes. Okay. Though this is a list, but for L1, this is one single value. Okay. So you will get 6. So total values is 6. And what is the indexing? Indexing will range from 0 to 5. So this is the 0th member of L1. This is the 0th member of L1. This is first member, 1th member, not first, but 1th member basically, right? Because, we start first from 0th. Then 2th, 3rd, 3rd, 4th, 5th, right? So how do you read the member? You read the values from the list by saying print L1 of 0. It's called indexing. So see here, two things. We are learning to use square bracket for both declaring a list and also reading a value from a list. Okay. We are reading the member of a list using indexing. Okay, so for indexing also you use square bracket, and for declaring a list also use square bracket. Now, indexing, you use square bracket for all of these. And in fact, later, okay, for data science, we'll talk about NumPy, pandas, etc. Okay, so for all of them, indexing, we always use square bracket. Whether you're indexing values from tuple, set, dictionary, NumPy, pandas, we use square bracket. But for declaring, only list is declared using square bracket. So how will Python know that you are declaring a variable or you are calling a member of a list? It knows because when you only have square bracket, nothing, no text before or after, that means you are declaring a list. When you have a variable name before the square bracket, then you are reading the value from that variable, which is just before this square bracket. Make sense? So now when you run it, so L1 of 0 will tell you 10 because this is the first member. Okay. So we'll stop here for today. We'll continue list in the next session.